Okay, topic 14 is on volume. So here's the problem we have from our sample sig test. This is a pretty good example, particularly with ones with a calculator. So we have find the volume of the region in the first quadrant bounded by the curve y equals 3 cosine x and y equals e to the x, and we're going to revolve it around the line y equals 5. So first of all, graphing it is bounded above by the cosine graph, that's the one in red, and below by e to the x. The region that we're referring to is this region right here. It's just in the first quadrant. So you got to find the intersection point. The intersection point, when you use your calculator to find it, just use the intersect command. And then store that answer into A. Just take x, store into A. It makes the problem go a lot easier when we go to actually evaluate the integral. Now I'm going to draw in my rectangle, my axis of revolution, and then it's a good idea to draw in your radiuses just so you can see what you're working with. So when I hit the rectangle for the first time, that's little r. Big R was hitting the bottom of the rectangle. So I got to do big R squared minus little r squared. So if I look at it, it's going to be pi. Don't forget your constant. The integral going from 0 to a, which I already defined. Upper was 5. Lower was e to the x. That's for big R. And then I square it. Then it's minus little r was 5. That's upper. Minus the lower was the cosine curve, which is 3 cosine of x. And that's squared. Now, when you go to do this, you could type this into your calculator to go and evaluate it. But if you use your calculator to graph it, you already have in y1 you have 3 cosine x. In y2 you have e to the x. Take advantage of it. So if I wrote it as the function integral of 5 minus y2 squared minus 5 minus y1 squared comma x comma 0 comma a, I'll get 5.405. But don't forget to add the constant, which is pi. Then if you did multiply it out, you get 16.980. Okay, part B says that find the volume of the solid whose base is a region in part A with cross-section perpendicular to the x-axis. So that's one of the reasons why I made my rectangle go up and down, because if it's perpendicular to the x-axis, I have to do it in terms of x. If it's perpendicular to the y-axis, I have to do it in terms of y. Whose height is 5 times the base. So it's going to be 5 times that rectangle squared. So we just have to punch it in. It's 5 times the integral. Upper was the cosine graph, lower was the e to the x. Notice that this equation right here is the same one you would use to find the area of the curve. But I got to square it. So it's a pretty typical one. And this one's pretty easy to type in your calculator, or you can use y1 and y2. In that case, you do y1 minus y2 squared when you use the function integral. But you should get an answer of 6.921.